So let's talk about doubly linked list. Doubly linked list is basically just like singly linked list, except like the nodes have a pointer to the next and a pointer to the previous. So that's the only difference. Otherwise, it's exactly the same. And we spoke about linked list in the previous video. So if you want to know more about it, just watch that video. Just like that video, create a class of node with a slight difference from the singly linked list, where we have this dot data is equal to data, this dot next is equal to null. This is the difference. This dot prev equals to null. So in the singly linked list, we just have these two. In doubly, we have the prev as well. This is the pointer. Then we have a class of doubly linked list, which has a constructor. This dot head equals to null, and this dot tail equals to null. Add a node to the end of the list. So we add a node to the end of the list, which is called append. Now we append something to the linked list. First, let's see const new node equals to new node. We create a node from the node class that we have here, and let's check if this dot head. So if the linked list is empty, we don't have head, it's like that. Let's comment it out. What we do in that case? Well, what we do, we say this dot head equals to new node, and this dot tail equals to new node. This is because when the list is empty, here the value becomes head and tail by itself. Else, if it wasn't empty, new node dot prev equals to this dot tail, this dot tail dot next equals to new node, this dot tail equals to new node. So what we did here, we basically say if it wasn't empty, the class new node that we created, the previous pointer goes to tail. The next pointer of the previous value goes to our new node, and this dot tail becomes to our new node. So if I explained here, we have this new node. What we do if we want to append it, we say like the previous goes to the tail. The tail's next, instead of null, goes to our new node, and our new node becomes the new tail, just like that. Okay, so the append, let's try it. Class doubly equals new doubly linked list. Okay, doubly dot append hello. Sorry, const, not class. And let's console.log doubly. Let's see what we have. We have a doubly linked list where the head is hello. It points to null. The previous is null as well. The tail is the same thing, hello. Next is null. However, if you want to append something, now because our linked list was empty, this is in the head. Now let's say bye. Head is hello. Next is bye. So now bye is our tail. Bye, which points to null. So the append is okay. The append seems to be okay. Now let's add a node to the beginning of the list. We call this one preprend, and this takes data just like append. We create a new node just like we did, and it takes data. If this dot head, if we didn't have head, just like the other, is equals to new node, and this dot tail equals to new node. Else, new node dot next, so our new node, the next pointer will become this dot head. So the head, wherever is in this place, when we introduce a new node, our new node, the next pointer will go to the head. the head's pointer goes to our new node. So that's what we are doing here. New node dot next equals to this dot head. This dot head dot prev new node. So the prev of our head goes to new node as we explained it. This dot head equals to new node, and the head becomes our new node. Now if we try this one, doubly prepend, and let's say this one is a lake. Now lake is our new node, which points to hello. Now let's delete a node by value. So this is deletion process. We say delete data. We create a pointer called current, which is this dot head. So basically the current head is the pointer. We do a conditional or a loop while current, while we have head. If current.data is equal to data, if the data inside the current, the head, is equal to our data, then we have another conditional. If current has prev, if it has a previous pointer, then current.prev.next equals to current.next. Else, this dot head equals to current.next. So I'll write this function down, then I'll explain it at the end. If current.next.prev equals to current.prev, else this dot tell equals current.prev, at the end return at the end current is equal to current.next. Okay, let's explain one by one. We create a pointer which points to the head, while we have current. If current.data was equal to data, equal to the data provided, if current has a previous value, then current.prev.next equals to current.next. Say you want to delete this node. So if it has prev, then current.prev.next. So basically this pointer goes to current.next, to this point, meaning this will be deleted. So current.prev.next equals current.next, that's like that. Else this dot head is current.next. So basically the head becomes our current.next. Else this dot head, so if we didn't have any previous value, basically you want to delete the head, and so that this dot head becomes our current.next value. So if I explained here, basically if this was what you want to delete, if there is no previous value, then this current.next, which means this value, becomes next. Okay, if we have current.next.prev equals to current.prev, the same process like this, and this dot tail becomes to current.prev. It's exactly like the repetition, just think about it. Current next pointer, previous pointer of the next, becomes current.prev. Now let's delete something. Let's delete hello, and we say delete. See if this works. Okay, head is lake, sorry, which points to buy. So now this works. Let's just use it to print something. Let current another pointer, this dot head, while current console.log current.data, current equals to current.next. So what we do here, we basically say, while we have head, this dot head, show the value of head, then it go through the values, like current is equal to current.next. And if we try this, we say this doesn't need an argument, so doubly.print, we should see the values. Yeah, lake buy.